Hey everybody, it's Dr. J, and today we're talking about titrations. Let's talk chemistry. Alright, so a titration. We kind of went over this in Chem 1, but of course, we're adding another layer in Chem 2. But just to remind everybody, a titration is basically when we're adding, right, a known concentration of a particular substance, and then we're reacting that with the unknown substance. And basically, we're trying to figure out the concentration of that unknown substance. Okay, so in order to do these type of things, right, we use this technique called titration. All right, that's essentially what titrations are. They're going to help us find the unknown concentration. So typically, people are using titrations to find the concentrations of your acid or base in solutions, as well as you can find other concentrations of other chemicals. All right, but usually, right, we're talking about acid and bases. Titrations are the most common, the most simple, and as well, of course, the least expensive way of figuring out these concentrations. This is one reason why you always see this in your Chem 1, Chem 2 lab, right? In every single university, everybody does a titration. And that's just because, right, it's a simple concept to teach, and it's very doable for any type of budget. Now, if we're titrating basically an unknown acid with a known amount, then of course we're going to have to go back to our equation that we're using, right, to figure that out. M1V1 equals M2V2, right? So this relationship can help you determine, right, your molarity or your concentration of whatever you're looking for. Okay. Now, when you find that by using this equation, depending on what you're doing, right, once you find the unknown concentration at the equivalence point, so this is the equivalence point to where basically you add enough to where basically your moles of your acid equals the moles of your base. Okay. So in order to determine when we have reached the equivalence point in the acid-base reaction, we're usually going to use an indicator, right? So these words, right, should sound familiar. If not, if this is your first time, it's okay. So once again, titration, we're trying to find an unknown, and that's usually going to be acid or base. And then once we reach our equivalence point, that's when we are talking about our moles of our base equals the moles of our acid. And then we know this by the indicator. Let's talk about indicators, right? Indicators are generally going to be weak organic acids or bases. Okay, and basically once we reach that point in our reaction to where we reach the equivalence point, that's where we see our indicator change the type of color. So for instance, right, the indicator could start off as red, but once it reaches that equivalence point, it turns to a whole different color, right? In this case, blue. Right? It just depends on the type of indicator you use. But yeah, we're going to see this intense color change for when we reach that equivalence point. All right, so for most of the time, you're not using a super huge amount of these indicators. You're literally using a couple of drops in your titration, right? And a couple different things people forget is that these indicators are usually an acid or base. All right, so if you add too much, right, that's the only reason why we add a couple of drops is because it's going to impact your titration. Very common one is phenolphthalein, right? Most Chem 1, Chem 2 labs are going to have phenolphthalein. And this is what it looks like normal, right? Acid form of it. And then once it reaches that equivalence point or that basic form, it turns to that peak red. Right, so if you guys ever did your acid base titration before and it changed to this pink red, probably use phenolphthalein. All right, so that's probably what you use as your indicator. Here's some other common indicators, but just depending on your indicator, it's going to impact, right, which one you're going to use. For example, if you're expecting a change to occur early on, as far as if your pH is low, you probably want to use one of these indicators, right? Or if you, in this case, phenolphthalein, if you expect your pH to change around then, right, you're probably going to use phenolphthalein because it's 8.3 to 10. So it really just depends as far as which one you're going to use, but all these have their benefits and cons to them. For example, in titration, right, if we have our equilibrium expression, we got our Ka, right, when we're seeing the color change, So once again, the color change occurs when we reach our equilibrium point. Moles of reactants equals the moles of our base. We can see that here, right? Everything's equal out to each other. So when this happens, this is basically when we reach our ratio is going to be 1 to 1, right? Because our moles of our reactants and base equal each other. So because it's 1 to 1, essentially our Ka value, right? This is at another layer, right? When we talk about titrations. So essentially, now that we know about Ka, our Ka value is going to equal our concentration of our H plus. So this is actually what we call the midpoint, right, of the color change. Or if you want to, you can do the pKa equals the pH at the midpoint of the color change. All right, so either way, it's going to give you the same. All right, so I have a couple of graphs to show just to finish up this titration concept. If you're titrating an unknown strong acid, so we don't know the concentration of our strong acid, but we do know the known amount of our strong base. This is usually what the typical graph is going to look like. Once again, we're graphing it by pH, and then we're paying attention to our strong base, right? Because we know that concentration, so we need to know how much we're adding. But what we're going to see, right, over time with all titrations, nothing's going to be happening. Then it just reach that point to where everything changes, right? So depending on which indicator you use, right, you're going to see that at different places. But essentially, right, we're going to reach this equivalence point around the pH of 7, right, where it goes neutral. Yeah, and then, right, we use phenolphthalein indicator. You can see it up here. Methyl red indicator. You can see it down here. But this is the typical graph for when you have a strong acid and a strong base. In this case, if we're titrating the unknown strong base with in this case, now we know the known amount of our strong acid, right? It's still very, very similar, but notice, right, where we're starting off this time, right? So in this column, we're paying attention to the amount of acid we're adding over time, right? Because we start off with a basic solution, so that's the reason why the pH is so high. And then eventually, as we add more acid, it starts to decrease until eventually we're going to reach that equivalence point to where they both equal each other. And then once again, the different indicators show the regions that they measure out there. Now here's a graph of when we have an unknown weak base, but we know the strong acid concentration. So we can see, right, in this case, it's a weak base. We're starting off with that and we're adding our acid. So it's still high, relatively high. But eventually, as we add, we're going to see that the equivalence point is a little lower this time. In this case, the best region or the best indicator used might be that methyl red, right? Because it's not neutral or anything like that. It doesn't produce that neutral solution. More, in this case, more a little acidic. But, you know, it all makes sense, right? Because we got this weak base and strong acid. Okay. So you know that deals with the salts, right? It goes back to the salt solution, all that type of stuff. Look at that video. If you got any questions about that? But you know, this is what the titration is going to look like in this case. And then let's look at the last graph here. We got our unknown weak acid, so we're starting off on the low pH side. We're adding strong base because that's what we know. And eventually we're going to see our equivalence point a little higher this time. So methyl red wouldn't be a good indicator. We'll probably have to use phenolphthalein this time to see that color change. And then from there, that's where we reach that equivalence point.